Hello everyone. Today we're going to talk about inverse Trig's functions derivatives. So today mostly I'm going to give you a bunch of rules, and then you're going to go ahead and practice taking some derivatives. Okay. So our first rule, so this is inverse Trig derivatives. So our first rule is if we take the derivative of arc sine, we get 1 over the square root of 1 minus x squared. All right? And remember, arc sine is our inverse of sine. So you could also write this as sine to the minus 1 of x. So that's the same thing. Throughout the lesson, I wrote it all as arc sine, arc cosine, all of the other functions, but you you can write it as sine inverse as well. Same thing. Okay. So now let's think. What might arc cosine be if we have 1 over the square root of 1 minus x squared? So take a second and think about that one. So how might these two relate? Okay. So it's going to be a very similar form. I want you to think about how they're related. So I'm going to come back to this one. I'm going to do tangent first. I'm going to give you a second to think about what the derivative of arc cosine would be while we do tangent. Okay? So if we do tangent, we get arc tan of x is equal to 1 over 1 plus x squared. So sometimes it's written as x squared plus 1. But it doesn't matter. It's 1 plus, and then for arctan, there's no square root for this one. So any ideas of what arc cosine might be? So it's almost the same thing, but it's minus 1 over the square root of 1 minus x squared. And it's the same reason as before. When we take the derivative of sine, we get cosine. When we take the derivative of cosine, we get minus sine. So if we take the derivative of arc sine and arc cosine, all it's doing is differing by a negative. Okay? So let's look at some examples now. Let's say we want the derivative of arc sine of x squared. So what we can do is we use basically just our chain rule here. So if we take the arc sine as our f of x, so arc sine of g of x, and our g of x is x squared. We take f prime of x. Arc sine we know is 1 over root 1 minus g of x, but then squared. G prime of x is 2x. So we would have 1 over square root of 1 minus x squared, and then times 2x. Right. Let's do another one. Let's look at 1 over arctan. Okay? So if we have d dx of 1 over arctan of x, let's rewrite it. Remember, this is the same thing as arctan x, but let's put the whole thing in parentheses and write it to the minus 1. Okay, and then again, we're going to be able to use our chain rule. So we're going to use almost this same derivative twice here. So I can pick, remember when we have powers, we always do g of x to the minus 1, and then g of x is arctan. Okay, so our f prime of x, we can do minus g of x to the minus 2. That's our power rule. Move the power to the front, subtract 1 from the power. Then g prime of x, we know is 1 over 1 plus x squared. And then when we plug it all in together, we would get negative 1 over arctan of x squared. So remember, that's the same thing as minus g of x to the negative 2. And to the negative 2 power means we can move it to the denominator and square it. And then times g prime. So we'd have this. And then we can leave it here. No need to simplify past here. Okay. I'm going to give you some more rules now. The derivative of arcsecant x is 1 over the absolute value of x, square root x squared minus 1. And the absolute value of x here has to be greater than 1. Okay? So if we have something like the derivative of, let's say, arcsecant x of 5x to the 4th, sorry, not arcsecant x 5x to the 4th, just arcsecant of 5x to the 4th. That would make a little bit more sense. Then we could write this as 1 over the absolute value of 5x to the 4th times the square root of, we're going to have to go ahead and square our 5x to the 4th, so 25x. If I have 4th squared, that's to the 8th power, and then minus 1. So I'm just plugging in 5x to the 4th for my x squared. But then I have to be careful. I also have to multiply by 20x to the 3rd. And remember, it's the chain rule. If I have 5x to the 4th, I'm multiplying by g prime. I didn't write out the f and g like I did on the last one. You can. You'll get the same thing. It's just, we can see that if we're multiplying something like 5x to the 4th, we can just multiply the whole thing once we plug it in by the derivative of it. So 20x to the 3rd here. Okay. And then we have to be careful. We just have to note that 5x to the 4th has to be greater than 1. So just a little domain restriction there. And we don't need the absolute value here because anything to the 4th power is going to be positive. So the absolute value doesn't have any meaning here. Okay. So let's do arc cosecant now. Arc cosecant x is just minus 1 absolute value of x square root of x squared minus 1. So they're not too hard to memorize here because it's the same pattern. If we have the minus from the arc cosine, we have the same thing for the arc cosecant. So they're almost the same thing, they just differ by a minus sign here. And then arc cotangent is minus 1 of 1 plus x squared. I'm going to give you, to finish today, a few identities. They might be helpful in some of the practice problems. You don't really need to use them, but it could be helpful if we have something hard we're trying to take the derivative of. So if we have the arc cosine of x, it's the same thing as pi over 2 minus the arc sine of x. And this is just back to pre-calc, thinking about the periods of how sine and cosine related to each other. If we take the arc cotangent of x, it's the same thing as pi over 2 minus arc tan of x. And we can clearly see using these identities why we have some sign changes when we go back to what those derivatives were. And the arc cosecant of x is equal to pi over 2 minus arc secant of x. Okay. And of course, you can move these identities around. Arc cosine plus arc sine is always going to give you pi over 2. Arc cotan plus arc tan, always going to give you pi over 2. And so forth. However you want to move them around, you are able to use any of these. That's going to be it for today. I hope everyone has a great day, and please go ahead and try the practice problems on these. Have a great day, everyone.